Bismillah ar-Rahman ar-Rahim. In the last part, we discussed the continuity of the function. We said that a function is continuous at a given point. C if there are three conditions must be satisfied. The first condition was f of c is defined, which means that f has a finite value at that given point. Second condition, the limit of the function as x goes to c exists. And the third condition was that f of c equal to the limit of the function where x goes to c. And we started at this point that we said that for the polynomials, polynomials are continuous everywhere. Any given polynomial is continuous everywhere. For example, b of x equal to square minus 4x plus 5. This one is continuous everywhere. Means from minus infinity to plus infinity. Any point between minus infinity to plus infinity, the three conditions will be satisfied. So for the polynomials, they are continuous everywhere. But the second one was the rational function. And rational functions we mean that f of x that will be written as polynomial divided by another polynomial. If we have rational functions. So for the rational function, if it is polynomial divided by another polynomial, then it is continuous everywhere except at the zeros of the denominator. So if we have f of x is equal to x squared minus 4x plus 1 divided by, let's say, x squared plus 5x plus 6. This is the rational function. And it is polynomial divided by another polynomial. For the numerator, it is continuous everywhere. For the denominator, it is continuous everywhere, if we just take them separately. But if we take the division, polynomial divided by the second polynomial, by the denominator in this case, this is continuous except this will be continuous except at the zeros of the denominator. When the denominator is equal to 0, then the function is not continuous. Then the rational function is not continuous. Now the zeros of the denominator, which can be found by factoring, it is x plus 2 multiplied by x plus 3 equal to 0. This means x is equal to minus 2, x equal to minus 3. So x equal to minus 2 and x equal to minus 3, we call them the discontinuity points. So these are points of discontinuity. Call them, these are points of the discontinuity. So we can say that the function, sometimes we say that f of x is continuous over all the real number except these two numbers, minus 2 and minus 3. Another way of writing that the function is continuous. So this function in general, the rational function is defined or is continuous everywhere except at the zeros of the denominator, where the q of x equal to 0. So f of x, p of x divided by q of x, there is a condition for the rational function that q of x is not equal to 0 to be defined or to be continuous. So this is the second part of the theorem, that rational functions are continuous everywhere except at the zeros of the denominator. So by this example, we say that the function is continuous at a given point if the three conditions are satisfied. Sometimes we need to find or discuss the continuity over interval a to b. It is the same thing. Any point given in that one we say that f of x is continuous over or the interval ab f of x number 1 is continuous over the open interval, or we can say that f of x is continuous at any point c belongs to the interval a b open, and also for the boundaries of the interval number 2 f of a and f of b are defined. Third one, we are speaking about the interval a and b. For a, we should have the right limit, and for b, we should have the left limit. So for the third one, f of a must equal to the right limit of the function as x goes to a plus, and f of b must be equal to the left limit of the function f of x as x goes to b minus, means the left limit. If these conditions are satisfied, we say that the function is continuous over the interval a, b. Let's take some examples how to find or to apply the continuity of the function. See this one? Example number 1. Find the value of some constant k for which the given function is continuous. At x equal to 1. And the function is f of x is equal to k x squared plus 2. This is when x is than or equal to 1. And x squared minus 1 divided by square root of x squared plus 3 minus 2. When greater than 1. Now we need to discuss the continuity of this function or find the value of k so that the given function is continuous when x equal to 1 or at x equal to 1. When we say that at x equal to 1 and the function is continuous, means we have to satisfy the three conditions. The first condition, f of 1 must be defined. So we need to find the value of the function at x equal to 1. F of 1 means x equal to 1. When x equal to 1, it is this part, the first one. So we replace 1 in the first part, which is this one, k multiplied by 1 square plus 2. This will equal to k plus 2. So we have to find the value of the function f of 1 is equal to k plus 2. And this must be defined for the function to be continuous. Second condition, the limit of f of x as x goes to 1. But since we have a greater than or less than, it means I have to find the two limits, left and right. Limit f of x as x goes to 1 minus, and limit f of x as x goes to 1 plus. Now for the left limit means x is less than 1. So this is equal to the limit of k x squared plus 2, where x goes to 1 minus, and this is equal to k plus 2. Just replace x by 1. For the right limit, this limit of x squared minus 1 divided by x squared plus 3 minus 2, where x goes to 1 plus. Now for this one, if we replace x by 1, I will have 0 over 0. This will be 0 over 0, which means I have to simplify it. And simplifying this one, we need to multiply by the conjugate. To simplify it, we need to multiply by the conjugate. And the conjugate of the denominator is x squared plus 3 plus 2 divided by square root of x squared plus 3 plus 2. We said that conjugate means we change the sign between the two terms. So this is equal to limit of x squared minus 1 multiplied by square root of x squared plus 3 plus 2. This is the numerator divided by down. It is a plus b times a minus b. So I will write it as difference between two squares. That is x squared plus 3 all square and 2 square. We are using the identity a minus b multiplied by a plus b is equal to a squared minus b squared. Just using this one. So I will have limit as x goes to 1 plus x squared minus 1 multiplied by x squared plus 3 plus 2 divided by down. We know that the square root will cancel the square, or square will cancel the square root. They are opposite of each other. So I will have x squared plus 3 minus 4. So this one, which is in the denominator, x squared plus 3 minus 4 is equal to x squared minus 1, which means I can cancel this one with the x squared minus 1. Now replace x by 1. Of x squared plus 3 plus 2 is equal to, if we replace x by 1, I will have 4. 1 plus 3 is 4, and the square root is 2 plus 2 is equal to 4. Now this is the right limit, and we have the left limit. Now the second condition, the limit must be exist. We know that since the function is continuous, f is continuous, means limit f of x as x goes to 1 exists. And exist means the left limit and right limit must be equal. This means this limit is equal, in our case, k plus 2, must be equal to the right limit. This is equal to 4. So it means that k plus 2 must be equal to 4. So I have now linear equation. K plus 2 equal to 4. This is a linear equation. Solve it for k. That will give me k equal to 2. So if k is equal to 2, then the function is continuous. So you can see now for this example, the value of k is equal to 2. If k is equal to 2, the three conditions are satisfied. F of 1 is equal to the limit, and from this condition we found that k is equal to the number 2. We take another example. Find the value of k so that the given function is continuous. Continuous at x equal to 1 again. F of x equal to k x squared plus 1 over 4 f x equal to 1 and equal to x squared plus 2 minus, this should be plus 3, minus 2 divided by x squared plus x minus 2 if x is not equal to 1. And again, we need to find the value of k so that the given function is continuous at x equal to 1, which means that I have to satisfy the three conditions. Or the first condition, that f of 1 must be defined. So just replace x equal to 1 in the first part. I will have k 1 to the power 2 plus 1 over 4. That will give me k plus 1 over 4. Second condition, limit must be exist. This is the second condition, so I need to find the limit. And in this example, I have x is not equal to 1. So I don't have x greater than 1 or x less than 1, which means that no need to find the left or right limit. Just find the limit as x goes to 1 because x is not equal to 1. Because this is the meaning. X goes to 1, it means x is not equal to 1. This is the meaning. So I need to find the limit. It will be the same either from left or from the right. So for this condition, we have limit of the function x squared plus 3 minus 2 divided by x squared plus x minus 2 as x goes to 1. And if you replace x by 1, you will have 0 over 0, which means that we have to simplify it. So I have to multiply by the conjugate to find the limit in this case. Conjugate is x squared plus 3 plus 2. Just change the sign between the two terms. And it must be up and down. So this will give me limit of, using the same identity that we have used before, a minus b multiplied by a plus b equal to a squared minus b squared. So the numerator will be just x squared plus 3 minus 4 divided by this one. I'm going to write it as product between two factors. It can be written as x minus plus 2 and x minus 1. Just factor the denominator multiplied by the second part, which is x squared plus 3 plus 2 as x goes to 1. This is equal to the limit. For the numerator, I will have x squared to be x squared minus 1, and down it is x plus 2, x minus 1 multiplied by x squared plus 3 plus 2 as x goes to 1. Numerator can be simplified more because we have that in the numerator. X squared minus 1 is equal to, we can write it as x minus 1 multiplied by x plus 1. This is the numerator. It is x minus 1 multiplied by x plus 1, which is difference between two squares. So you can see that x minus 1 and x minus 1 is a common factor between the numerator and the denominator. It is x minus 1 up and x minus 1 down. So my function will be equal to x plus 1 in the numerator divided by x plus 2 in the denominator multiplied by x squared plus 3 plus 2 as x goes to 1. Now replace x by 1. You will have up is 2, down will be 3 multiplied by 4. Just replace x by 1. 1 plus 1 is equal to 2, and 1 plus 2 is equal to 3, and in the bracket square root of 1 plus 3 is equal to 2 plus 2 is equal to 4. So this is 2 over 3 multiplied by 4, which is equal to 1 over 6. Now this is the limit for the function. And in the first condition we have k plus 4, plus 1 over 4. And from the continuity we have that these two conditions must be equal. The limit and the value of the function must be equal. This is the third condition. The third condition, f of 1 is equal to the limit. So in the first condition, we said that we have k, or the value is k, plus 1 over 4 equal to the limit, which is 1 over 6. So from this one, we can find k is equal to 1 over 6 minus 1 over 4. Which this will give me k equal to over 12. That will be 2 minus 3, which is equal to minus 1 over 12. So the value of the function, or I'm sorry, the value of the k in this example is equal to minus 1 over 12. So the given function is continuous if k is equal to minus 1 over 12. The three conditions will be satisfied at this value. If k is not equal to minus 1 over 12, then the function is not continuous.